Hi everyone. We'll be discussing some problems on equivalence relations today, and we'll see what makes them equivalence. So let's straight dive into the examples. So the first example that we have is the relation is a friend of, and we have to check whether this is an equivalence relation or not. So for an equivalence relation, it should satisfy three properties. The number one property is reflexive that needs to be satisfied, which is when we check that every element, whether they relate to themselves or not, if every element relates to itself also, we call the relation as reflexive. So let's take Harry. And generally speaking, everyone is considered a friend of themselves. So Harry would also be considered a friend of himself. And that means that Harry and Harry are related on this relation because Harry is a friend of Harry. And Harry is any general person. So this holds true for every person. Thus, that makes this relation reflexive because it is true for all. And so we put a tick mark here. Second property that we need to check is symmetric, which is when we say that if there's two elements that are related, say A comma B, then B comma A should also be related. And let's again take the example of Harry. Now this Harry might look familiar, and that is it. This is Harry Potter himself. So we have our Harry here, and we know that Harry is a friend of Ron. Now we need to check whether Ron also is a friend of Harry or no. Again, generally speaking, when we consider someone a friend of us, we also consider that we are their friend. There's no one-sided friendships that we are considering. And between Harry and Ron, we definitely know that they are friends. So Ron is also a friend of Harry. So our information that we had was that Harry is a friend of Ron, and this straight implies that Ron is also a friend of Harry. So this means this is a symmetric relation too. Because if Harry is a friend of Ron, then Ron is also a friend of Harry, and these two are any general person. So this relation is also symmetric, so another tick mark here. The last property that we need to check is transitive, which is when A and B are related and B and C are related, we need to check whether A and C are also related or not. Seeing the examples we have taken till now, I think we all know who the main character is going to be. Luna Lovegood. Luna Lovegood here we're going to take, which is a friend, I know, of Harry. Luna Lovegood is a friend of Harry. And I know that Harry is a friend of Ron. So Luna Lovegood and Harry are related because Luna Lovegood is a friend of Harry. And Harry and Ron are related because Harry is a friend of Ron. What we need to check is whether Luna is a friend of Ron or not. And this is not necessarily true. We know that Luna can be a friend of Ron, but it is not necessarily true. Right? So this is not necessary. And this means that if Luna is a friend of Harry and Harry is a friend of Ron, Luna being a friend of Ron is not necessary. So this makes this relation not transitive. Because again, here, Luna, Harry, and Ron are just examples. It applies to any general person. Harry is their mutual friend, but that doesn't imply that these two are also friends. So this relation is not transitive. And because it is not transitive, it is also not an equivalence relation. Let's take another example. So we take the set A of all books in the library given by the relation x comma y if x and y have same number of pages. Now checking the reflexivity. So considering the examples I've taken, you guys also know the book I'm going to take right now, which is Harry Potter and the Philosopher's Stone. And there it is, the book. Now I know this is probably not the best cover page of Harry Potter and the Philosopher's Stone, but hey, this is what we have. This is what we want to work with. And I know that this book has 250 pages, close to, right? So if I take any other Harry Potter and the Philosopher's Stone, same edition, everything's same, that book is also going to have the same number of pages, which is 250 pages. So that book and this book will have same number of pages, and then this would be related. So that would make this relation reflexive. Because I've taken this book, but it can be any general book, and any general book would have the same number of pages as itself. Thus, this relation is reflexive. Putting a tick mark here. Now let's check symmetric. So symmetric, first again I'll take my favorite book, which is Harry Potter and the Philosopher's Stone, right here. I know it has 250 pages. The second book I'm going to take is equally popular, if not more, especially among students. And that is The Diary of a Young Girl by Anne Frank. And this book right here also has 250 number of pages, close to, right? What we need to check whether this relation is symmetric. We're checking it with this example. So following up, we see that Harry Potter has the same number of pages as The Diary of a Young Girl. If I can show that The Diary of a Young Girl also has the same number of pages as Harry Potter, which is definitely true, because the number of pages here remains the same. So the Diary of a Young Girl would also have the same number of pages as Harry Potter, right? When their pages were same, I could write that HP, which is Harry Potter, and the diary belong to the relation R. So when the diary has the same number of pages as Harry Potter, I can simply write it as the diary, HP belong to the relation R, which is X and Y having same number of pages. And because this information implies that this information is also true, so this relation also becomes symmetric, which is amazing, because now I can convince my friend to leave Harry Potter and read a related book of having the same number of pages that might actually fetch him some marks. What is even more amazing, that we're using Anne Frank and Harry Potter in the same line, and that too to explain a mathematical concept. Okay, let's move on. Let's see the last property, which is transitive. So this is definitely symmetric. We're going to transitive now. So the first book that I'm definitely going to take is Harry Potter. And I know that it is related to The Diary of a Young Girl because it has the same number of pages, right? And think about it, that I'm on the aisle where The Diary of a Young Girl is kept. And I care for my friend. I also want him to have some great habits, some great lifestyle. So I find another book related to The Diary of a Young Girl on the same relation. And that is, we found Atomic Habits by James Clear. An amazing book, right? It is related to The Diary of a Young Girl because it has the same number of pages. So here we wrote HP and the diary are related. So they belong to the relation R because they have the same number of pages. Here the diary and the Atomic Habits are related because they have the same number of pages. So I write it like this. I need to check because now I need to convince my friend again to leave Harry Potter and read these books. So I need to check that whether they are related books so that I can convince him. So for that, let me keep all of the books on a table. So we have our Harry Potter, and I'm telling him already that it is related to The Diary of a Young Girl, so he can leave Harry Potter to read this book. Now I also place my Atomic Habits right beside The Diary of a Young Girl, and I'm showing him that, see, even these two books, they have the same number of pages, so they're also related books. And now, slyly, I take out The Diary of a Young Girl, and I show, see, Atomic Habits and Harry Potter also has the same number of pages, which is just 250 pages. So this means that they are also related. And when the Harry Potter and Diary of a Young Girl was related, I wrote it like this. When diary was related to Atomic Habits, I wrote it like this. So when Harry Potter is also related to Atomic Habits, I write it simply like this. So from this information and this information, it implies that this information also follows. That makes this relation transitive. And because it's also a transitive relation, earlier we saw that it was also reflexive and symmetric. That makes this entire relation equivalence relation. So thank you everyone. That was all the examples for today. Thank you.